So what is done for the physical layer? How is it made? How did they get some of the features, and why did they do these features, right? So first of all, they didn't want to invent anything new. So they took 11AC and took the same design except clocked it down by 10. What that means is, instead of 20 megahertz, they will use just 2 megahertz. Instead of 40 megahertz, they will use 4 megahertz. And use the same number of carriers. So 20 megahertz AC uses 64 FFT size and 48 data subcarriers. In AH, they are using the same number of FFT size and same carrier size, but only in 2 megahertz. Things are closer together. Okay. Now, when you put things closer together, there are two things happen. First of all, the carriers are very close, so there could be inter-carrier interference. Right? That's why you don't want to put too close. But there is the opposite effect too, and that is that the time, duration of the symbol, remember T, the FFT T is 1 upon F. If you remember, those of you at least who took the second exam probably remember it much better than who didn't. So 1 upon T, so symbol duration is large, 10 times basically. If the symbol duration is large, that means now you can have 10 times more multipath things that you can sustain. So basically it can go longer distances. So this is basically the reason that they kept the same carrier, number of carriers, so that they can sustain longer multipath interference. And all the time values are 10 times longer basically because of that. SIFs is 10 times longer. SIFs is remote short interframe spacing in 11. ACKs, now there are two things. The time before the ACK is 10 times longer. The ACK themselves are actually 0 length, as you will see in a minute. So the ACK comes 10 times longer after the packet is done. So SIF it used to come as a SIF. Right? Now SIF itself has become 10 times, so the ACK will come later, but the length of the ACK has been compressed, as you will see, to 0 length. Alright, so now you see the reason for the first decision. First decision is that 11AH is same as 11AC downclocked by factor of 10. Does that make sense as to how it is downclocked? Time is become 10 times longer in every respect. That's what is downclocked by factor of 10. Yeah.
Excuse me, you said that the symbol duration and time domain will be
10 times.
Yeah, 10 times more. So it means the intersymbol what?
Less.
Less?
Yeah, see what happens is, what we do is 1/4 of the symbol is reserved for, we used to call that some kind of gap, in symbol gap, that is a cyclic prefix.
Yes.
So what we do is, now we have a bigger cyclic prefix, and that cyclic prefix allows you to how many different paths you can take. If one path is straight and one path is going through a mountain there, it will come much later. So that delay is spread. Now with
but the data is really low.
That's what we want. Okay. See, the thing is, so that is the second effect, is that data rate is low. We don't want, remember, AC was running at gigabits. We don't want anything in gigas, we don't want anything in megas, we want everything in kilos. We are going in the wrong direction, right? I mean, in this case, we are going in, if you want to call it, in the direction of low rate. Alright, second thing is, everything else is as before. So now the thing is, some of these are things in the standard. We don't know how much of these will be in the products. So bonding, channel bonding was another thing that was there in 11AC. You remember 20, 40, 80, 160 gigahertz channel bonding. And so they have put here also, instead of doing all possible channel bonding, they said you can just bond maximum 2 channels next to each other. So you can do 1 + 1 to make 2 megahertz. And 1 megahertz actually is a new phi, which is coming up in the 0.5 later on. So all stations have to support 1 and 2. Now 2 is already defined as 20 megahertz. 2 megahertz is the same as 20 megahertz before. but then there is a new one for 1 megahertz. All stations have to support 1 and 2. So this is the minimum. If some stations are not big enough, they don't have too much money, too much power, they don't have to use 4, 6, and 8. 4, 8, and 16. Up to 4 spatial stream, again this is an option. Many stations will not implement that. And 1 megahertz is allowed a new MCS 10, which is MCS 0 with 2x repetition. Now, what is MCS? MCS is modulation and coding scheme. That tells you whether I'm using QPSK, am I using QAM 64, QAM 16, whatever, right? That is MCS. So every of these modulation is assigned a number. So there is a number from 0 through 9 for different coding schemes. Now they are double using this word MCS 0 for something totally different. And so if you use MCS 10, then it is MCS 0 with 2x repetition. So every bit is repeated twice. So it's like 1/2, 1 useful bit and 2 bits sent. So all of previous ECCs and everything is there, plus on the top of that, everything is repeated twice. And with that, you can go even much longer. Why? Because now you can sustain even more errors. And if one of the 2 bits is received, you receive the bit. Right? 50% error rate is okay. And so that is MCS 10. And 9 times longer than 2.4. So here is a fair thing to say about this. 9 times is not because of the repetition. First of all, 2.4 and 900 already factor of 3 right there. Right? 900 times 3 would be 2.7. So factor of 3 is already there, right? So the 900 will go without any repetition, without anything, 3 times more. But with this 2x, it goes 9 times. Okay? So again, this decision is made because the distance is important. And the data rate is not important. What we did was we cut the data rate to half. Right? We are sending 2 bits and only 1 is used. So we are cutting the data rate to half, but we are reaching the distance longer. And then beam forming to create sectors. So the thing is, you don't have to put our energy in 360 degrees. You can put it into sectors. No big deal there. So many of these things actually just came straight from AC. AC has beam forming, AC has spatial stream, AC has bonding, and everything else. So they just took all of that, but biased them in the direction of low rate, long distance. Any questions about any of these? Yeah.
You said that you said this double repetition. What was the other reason that you said it goes longer?
Longer is because of frequency. Okay. 900 megahertz will go 3 times longer than 2.4. Actually, 2.4 will go 2 times longer than 5.8, right? Actually, I did an experiment at my home yesterday. So I have a dual band router, and I was not using 5 gigahertz, I was using 2.4 gigahertz, and my son complained that, oh, it's too much, we don't get good internet, this and that. So I was looking for as to how to improve the wireless internet in our home. 5.8 to the place where we want the internet to be from the router, which is the other end of the house. 5.8 had minus 70 dB from the same router, and 2.4 had much higher power. Actually, it was like minus 60 dB, 10 dBs more. Okay? So that is the thing, is that 2.4 reaches much farther, and maybe my even neighbor can probably listen to 2.4. Okay? 5.8 they cannot. However, there was another interesting fact, and that was that 2.8, even though it had higher power, had higher interference, which was not showing in that number. And so when I did the data rate measurement, 5.8 was much faster. Okay, with a lower signal, but there is a lower noise. With 2.4, higher signal and higher noise. Right? Everything else runs on 2.4. Your phones run on 2.4, everything else runs on 2.4, your microwave runs on 2.4. So 2.4 actually I mean, previously I had not done this combined experiment where you do look at the signal and look at the data rate. So the higher signal does not really mean higher data rate. But anyway, coming back to this point here is that the shorter wavelength go much farther, and you can see it right in your home, right in your department. And actually, so what I have done as a result is at the end of this lecture, there is a lab you have to do. You have to do exactly what I did. So that you become experienced with using the wireless tools. You become a wireless expert if you don't even know how to measure the power, or how to find the power, or how to set up something. It will not be very good. So you have to play with Insider, which some of these guys have played with who are working on the projects, and other things. Okay, all right, back to this is done. Phi is done. Mac. So the Mac had several challenges. First challenge was large number of devices. So how many devices? Wi-Fi can support 2000 max. Actually, it cannot support 2000. If you put 2000 computers in this room and one access point, I think it will die. But by design, it cannot even address more than 2000. You cannot even ask them that, okay, please tell me what you want. So 2000 is the limit, design limit of 11, rest of the other 11s. So 11 AD, people wanted, except 2000 is too small. I mean, we might have sensors with, meters or whatever we want to read, more than 2000. So they need to do some kind of hierarchical identifier, which I will explain in next slides. And second thing is, generally in Wi-Fi we don't use relays, but I think we have seen relays somewhere, and I don't remember where we saw it, but we will see lots of relays when we come to cellular phones. And so what they do, I think we saw in 60 gigahertz relays. But here they will have similar concept. If you cannot reach some neighborhood far away, you can put a relay there, and then it will come to, you will come 2 hops. So that is another trend I had talked about in the last class, that people are not going for mesh. Mesh is an interesting topic for academics. All the academics are publishing a lot of paper on how to do mesh networking because it's a good mathematical problem. But in the real world, it's a very messy problem. Nobody wants to send other people's packet through their battery, using their battery, right? So it doesn't succeed. So anyway, here it is relay, and the relay is not battery operated. Relay could be mains operated, and relay could be connected to whatever. And so its job is to just transfer packets. 2 hops, that's it. Power saving and enhancements. And then of course the power is the main thing. So now they allow everybody to sleep, including the relays and the access points, and sleep much longer. So they don't have to sleep for a second or minutes or hours. They could sleep for days. Okay? So you are not reading your electric meter every minute or every hour or every second, right? You are probably reading every day. So that kind of sleep is allowed. And you just negotiate your target wake-up time, and you say, well, I want to wake up every 3 days. Okay, all right, you got it. And then speed frame exchange. And second thing is, when you wake up, do all your job and go back. So you do a lot of transmission in one attempt, and you can go back to sleep. All right, and I will actually, I think I have other slides and a lot of slides on all of these points, except the relays I don't have, but I think relays is kind of trivial now.